Thank you, everyone. Appreciate being here. It was I got this invitation from another event I did about 2 months ago, and we're focused on global applications for the supply chain using LoRaWAN. So we started out a bunch of executives working in cold chain. We've been in cold chain. I've been in it 12 years. And what we started to see was the growth of that industry and how temperature monitoring control of assets across the globe was critically important to everybody, from medicines to meats and so on. So we started digging deeper. And back then we were doing refrigerated container monitoring. And we started exploring the use cases of LoRaWAN in that field. So we were the first to put in a LoRaWAN gateway in a refrigerated container back in 2016. Today there's over 300,000 of these out in the world. They transit in over 170 countries. And the purpose of LoRaWAN in this case was to communicate to sensors inside the container from a device that was outside the container. And that use case allowed us to do pallet level tracking, door sensing, ethylene, CO2, O2, a mixture of things that allow everything from perishable foods to security for high-value pharmaceuticals, etc. I'll just get here. So what we started seeing too is in the IoT market, there's 1,000,001 platforms. Everyone wants to track everything. They're throwing hundreds of millions of dollars in order to do that. So how do you differentiate in something like that? So what we are is IoT data aggregators. So we collect data, we provide robust APIs, and then we pass these through on network coverage. So we look at a bunch of different things. One is the emergence of LoRaWAN to satellite and the benefits of that, which I'll talk about further in this. The other time is how we apply real-time intelligence and we run data on the edge of the device as well as in the cloud to come up with the best result. And the result ends up being either displayed on a system. Obviously, we have a platform, but our focus isn't the platform. Our focus is to provide data to those who need it, where they need it. And that sometimes means process data. So we take data. For example, we collect timestamps and those things, and we can do predictions and ETAs, run algorithms, and we add that to the stack in order to get the best result. So supply chain IoT, I mean, it's still in the early stages, right? Driven largely by forces like the pandemic, where no one could see where their stuff was, and it became really critical that people get their things on time. So we would have container delays, they're stuck out in the ship in the harbor, they have issues with clearance times, there's not enough chassis to pick up containers, there's not enough drivers, not enough trucks, and this just rolls right down the supply chain. So when we looked at the overall footprint, we thought that there was a way that LoRaWAN could play in this space. A lot of the data that's exchanged throughout the global supply chain are tiny bits of data. It's not mass downloads. It's little pieces of data that are on a recurring ring and they go round and round and round. In our industry, they had EDIFACT messaging, which is 35-year-old technology, still used today, right? Little messages that say, I'm offloaded here, I'm onloaded here, I've entered a gate here, I've exited here. The issue with that is that those are manual processes. Some of them are partly automated today, but some are still manual in many parts of the world, so what you have is no standardization. What IoT gives you is a set metric for every single asset reporting at a specific time. You have a one source of truth, and that has been really the main reason why you would adopt this, because it gives you certainty. Carriers today don't have certainty. Shipping lines don't have certainty. So when is it arriving? Well, they can tell you early or late, but they give you a date, and 87% of the time they don't hit it today. And that's part of the problem. When we looked at the technology, we looked at the LR1110, the LR1120, these changes that have been hitting the community have been impactful for many ways. Number one, you can roam on these. Number two, there's localization technologies on these. So without needing GPS, which is a power-hungry chip, you're kind of in a place where you can start to give localization of data without spending that amount of energy. One of the big things that this technology has over what is used today out in cellular world, and we're seeing this already now from early adopters, is that it's a consumer-driven market. You want a phone, you want a brand new phone every 2 years. They want you to buy a new chip every 2 years, every 4 years. So they're accelerating the proliferation of the network. But in supply chain, you want to install an asset because it costs money to go there and do that, and you never want to touch it, hopefully for the life of the asset. But we're not there yet because battery technologies haven't gone that far, but LoRaWAN is able to do a lot of the battery savings that way, and we feel that we can leave these on assets in the field for 10 years and not have to touch them. This is extremely compelling to logistics operators. So I have a maturity index here for various pieces of supply chain. So how many marine dry containers there are, how many rail wagons there are, how many containers in transit, which you would use a per trip sensor for, whether it's security for door, or temperature, or humidity, chassis and trucks. They want to know what container's sitting on the chassis at any given time because they bill on that. They want to know the container ID when it comes onto the chassis as well because they're using that to equate on the supply chain. These are a lot of things we get asked. But the exciting stuff starts to come down when we start getting to pallets. Almost 10 billion pallets in the world. And now we're seeing the move towards plastic pallets. So now you have reusable pallets that really help this use case. But then you start getting into parcels. And I think now is the beginning of that starting to happen. I don't know how many of you knew this, but Amazon has a project called Sidewalk, and every single Alexa has a LoRa chip in it. What they're using it for today, no one knows for sure yet, but I can tell you something, it looks like they could create their own network for parcel delivery that's automated in the future with light sensors whenever boxes get opened, and they can help in returns and understand people's buying patterns and return patterns. And it can save them a lot of time and make them a lot more efficient. The market, as you see, is disjointed. A lot of the operations here are still manual. People are still operating off Excel spreadsheets, and a lot of these things can be automated. The ETAs are still unpredictable, as I mentioned earlier. There's slow adoption. The cost feasibility has been the one thing that was stopping the industry from moving forward. But we're getting to somewhere where this can scale quickly, and the numbers that we're seeing from supply chain actors wanting to deploy technology are in the tens of millions. These are big numbers. And the real question is, how can you make it compelling for your customers to deploy? What is it that's going to make that trigger that's going to allow them to do that? Many cases, it's return on investment. And what helps return on investment? Well, first of all, a low-cost device is probably the number one thing. And cellular chips have struggled with that, especially when you look at dry container market adoption. There've been some lines that have now announced full fleet capabilities. They want to start deploying 1 million here, 1 million there. You're going to see that increase. They predict over the next 7 years that 1 million will go to 8 million, right? In just container. But what's more critical is inside. We suspect that the parcel and package and pallet market will probably double the container market in terms of speed of adoption because it becomes twice as critical at that point. What are the market priorities? Well, cold chain monitoring, and Dan had obviously he's done a lot in the restaurant space. He was just on here. Cold chain monitoring is jumping to a $45 billion industry. These are huge numbers. And there's enough space for many, many actors. What I've long noticed in the LoRaWAN community is a lot of hardware, and it never translated to solutions. And I'm so happy to see when I look out on the floor, lots of solutions coming up now. People are getting to the use case. They're getting to the return on investment because it's the only way that you're actually going to get over the finish line, right? Deployments are trending up. Data scarcity is obviously, we have increased use cases. Dan mentioned a whole bunch and some that I actually never thought about. And I was in the restaurant business before joining shipping. So quite interesting. So dry marine containers. They go on the door. A marine container life is 10 years for an active carrier. The top tier carriers will drop the asset after about 10 years, and then it'll have another 4 to 7 years in a secondary market. where the device could probably still stay on and add value. So these are the kinds of numbers that we're looking at. What's interesting about LoRaWAN is the signal remains the same. No matter what the chip, you're still going to communicate the same way all the time. And that could be the #1 sustainability reason why someone would pick a LoRaWAN solution over necessarily a cellular one. Because to replace the entire fleet on a dry container across 50 countries where you have your massive throughput is going to take 3 years, 4 years, and at what cost, right? These are questions. These are things that always come up. On chassis and trucks, they're fast-moving assets. They're going to be used more, so it's actually easier to deploy. But there's a problem in that one. They've never fully deployed chassis. Why? Because cost. Imagine, the chassis asset lasts 25 years. The thing that they change the most, tires, right? Everything else is metal. And all they want to know is, where is it at said point in time? So the value proposition has to match it, and a lot of that has to do is, where is it now? Because when they drop it off, the driver doesn't always tell them where it is, so they don't actually know physically where it is at points in time. There's applications here that can be low cost, that can allow deployments, and just in the United States alone, there's almost 1 million chassis, right? Rail, I saw a release this morning about rail wagons being tracked using LoRaWAN. I've seen a few articles, a few different countries starting to deploy. I think it's really interesting. I've had industry veterans in rail tell me, you know, there's just too much standardization. People are afraid of new standards, and I think it'll take forever. I think some countries will adopt it sooner, and it'll be like a wave. Once it comes, it'll just wash over everyone. So I do expect an increase of deployments on rail. Sites and assets, pallets, boxes, these types of things, because of the gateway configurations and the local network roaming. So on our side, the first sensor we built was a temperature sensor. It can communicate to cellular, like not cellular, but partner networks we have. So whether it's Things Network, whether it's Helium, whether it's EveryNet, and so on. And as it goes through the supply chain, it can pick up those networks. And then if the customer wants their own gateways in their own facilities, we would put one up and fulfill that supply chain need. So you can actually build trade lane visibility one customer at a time, one trade lane at a time. And the experience that we have is from deploying cellular and LoRa devices in over 100 countries over the last decade. But 10 billion pallets, I don't say all of them will be tracked, but what we're seeing is pallet pooling in a way that 10% of the fleet could have live devices, and the rest, because they ship them in sections and in bulk, the rest then come around that way. Right? So value propositions have increased, 300 million intermodal shipments every single year, year in, year out. Huge markets. The package market is even bigger than that. We're talking 131 billion parcels. And I do think that we're getting to a point where we're in single digits on the cost of these things now, and it'll come down to low single digits in the near future. And that's where the opportunity lies. So a fully connected ecosystem. Well, what does that look like in the real world? Well, what we did in the port of Antwerp-Bruges, which is the largest cold chain export port in Europe, is there's a Things Network set up right there. So we took the largest fruit exporter out of there, Food Care Plus, and we started a temperature quality monitoring solution. Driver takes a sensor, little guy like this, pulls the tab, the battery activates, pulls out his phone, opens his camera, scans the QR code, it opens up his email, he types in the pallet number or the container number he wants to affix it to, and he presses send. You can do that from anywhere in the world you have a cellular signal. So you're leveraging the two, but you're using the one, right? And these types of mixes of technology and how you make it super simple for the customer is how large deployments happen. They don't happen by saying, well, here's my cookie cutter thing, and I'm going to fix it. I can tell you by experience, in the 17 shipping lines that I closed contracts with, in only two cases was the solution exactly the same. So what you end up with is a platform and a solution that's very versatile, and you bring data in and you take data out and you show it on the screen and you don't show it on the screen. And that's kind of how it goes. Port of Miami, cold chain coming in from Latin America. They want perimeters. They want to know when stuff's on the way. Why? So they can predict what to do with it when it gets there. They want to know the condition beforehand. They want to know when trucks, trailers, containers are arriving at the port and where they are en route on the way in. So we're picking up all these signals of various shipments that are coming in and out of the port. Second use case. Third one, we're doing West Coast. We're doing all the way up from Vancouver on all the way down and tracking shipments that were going with a large third-party provider. They wanted to just track shipments in between their distribution hubs, only for efficiency. What's where, when, and how long is it taking, and when is it going to be there? So this was the initial use case for that deployment. And how does it look? Well, the gateways are up, and it timestamps the data, and this LoRaWAN one actually logs. So it's not required to have 100% uptime, but you log data when you're not able to connect, and as soon as you connect, you backfill the data. Critically important. And then for the last case, LoRaWAN to satellite, as I mentioned earlier. Really exciting. Why? Because no blind spots. What we're building with this group is a device that will roam on the local networks as this little guy does, but also when it can't get a signal, it'll go back up to satellite. So you're managing cost, but you're also filling in where even cellular can't, because in many places there's no cellular coverage. We know this from previous deployments, that a lot of countries, even the United States, there's a lot of blind spots. And if you can fill them in with a satellite, you have a competitive advantage that will allow you to deploy this technology as long as the units see the sky. The only cases when not, inside a warehouse, below deck on a vessel, but you can manage that. There's solutions for that. There's geofences for that. There's alternative data that you can bring in to know that it's on the ship. And I think we're getting to the point that we can easily say that we think this technology is going to be competitive in the future. Thank you so much.